All right, here we go. 3.4. This is linear programming. Now, before we actually get into linear programming, there's some vocabulary we've got to understand. Okay? And the first thing I want to tell you is when you have a system of inequalities, this system altogether are called constraints. Okay? So when I say graph the constraints, I'm just saying graph the inequalities. Same deal. All right? After you graph them, however they fall together, the shaded area inside, right here, this area is called the feasible region. Feasible. Feasible. I don't think so. Okay, the feasible region. Now, around that feasible region, we have 1, 2, 3, 4 corners. These corners are called vertices. You should, from geometry last year. Then, outside, after you've graphed this, you're always given what we call a profit equation. The profit equation is usually written as either P equals or C equals, depending. And it's going to ask for either a maximum or a minimum. If it's a maximum, you're trying to make the maximum amount of money. If we're looking for a minimum, usually it's the minimum amount of product you need. All right? So those are the different things we're going to find today. Now, today's steps, you stole my block. Today's steps, because we're only doing a little bit today. Step number 1, I'm going to ask you to graph the constraints. Come on. Yep. Graph the constraints. Step 2, I'm going to ask that you shade the feasible region. Step 3, calculate each vertice. Step 4, plug vertices. Into the profit equation. And step 5, determine the point that satisfies the required max or min. This is all we're going to do today are these 5 steps. That's it. And all of those 5 steps you already know how to do. Yes, Vance. Determine, the point. I was supposed to have the word point in there. Determine the point that satisfies the required max or min. Okay. Okay, so, yes. Graph the constraints. That's graphing the inequalities we've been doing for over a week, right? Yes. Because you can't, you know when we graph things, we're not precise, right? We have a general idea where they are, but we're not precise. We have to calculate that so we know exactly where it is, okay? So we already know how to graph inequalities. We know how to shade the region. We know between doing either elimination or substitution how to calculate the vertices. We know how to plug them into an equation. Yeah, we know how to do everything. All right, so this should be super easy. Here we go with example number 1. 2. Example number 1. This is how it's going to look when you go to turn to 10 through 12 all today. You're going to be given a system of equations, the constraints, and maybe I have 4x plus 2y is less than or equal to 16. We'll do 3x plus 3y is less than or equal to 15. We're going to do x is greater than or equal to 0. Y is greater than or equal to 0. And our profit equation is P equals 3x plus 2y. And I want to look for a maximum. Okay, so this is what your problem is going to look like. Yes. Okay, hold on. All right, so now, step 1 says we are going to graph the constraints. That's these 4 equations. X is greater than or equal to 0, and y is greater than or equal to 0. It just means the first quadrant. Okay? So it's only the first quadrant. Now we're going to graph the other 2. And I'm going to tell you the easiest way to do these are by your intercepts, your cover-up method. Now my cheat cover-up method is this is my x and this is my y. I put zeros. Put 0 in for x. That means y equals what? 8. Very good. And if I put 0 in for 8, that means x equals 4, right? So I'm going to plot those 2 points. I have 0, 8. Where did I get that from? Okay, so first I put 0 in for x, so this goes away. So I really just have 2y equals 16. So y equals 8, right? If I put 0 in for my y, that goes away. Now I have 4x equals 16. So x equals 4. Okay, so now I'm going to plot, first of all, 0, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Put a dot. I'm going to plot 4, 0. 1, 2, 3, 4. Put a dot. I'm going to go ahead and connect my dots. All right. So far I have the top equation graphed and the bottom 2 that say I'm in the first quadrant. Now I got to graph this one. Again, if I put 0 in for x, what do I get for y? I get 5. If I put 0 in for y, what do I get for x? All right. So I'm going to go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and connect my dots. Okay, so I have graphed them. Yes, Vance? You can't wait? Thank you. Yes. Okay. So now, it says that both of them are less than those lines. So the overlapping part is this funny little quadrilateral area here. Okay? That is shading the feasible region. That's my feasible region. Now on this feasible region I have 4 corners. 1, 2, 3, and 4. 3 of them are right on the axis, so they're easy to calculate. This one obviously is 0, 0. This one is right on the y-axis. This was at 0, 5. This one was on the x-axis at 4, 0. We have to calculate the 4th one, though, because that's where these top 2 intersect or cross. So I'm going to multiply my top equation by 3 and my bottom one by -2. right? I'm just doing elimination. 3 times 4x is 12x. 3 times 2y is 6y. I'm just doing equals because I'm just trying to find the point. And 3 times 16 is 48. Second equation. Negative 2 times 3x is negative 6x. Negative 2 times 3y is negative 6y. And negative 2 times 15 is negative 30. I'm going to go ahead and add these together. My 6's drop out, right? So I have 6x equals 18. So x equals 3. So that's got my x value. I need to find my y value. Got to plug it back in, exactly. So I'll plug it back in right here for x. So I have 4 times 3 is 12. Plus 2y equals 16. 2y equals 4. So y equals 2. All right. So I have 4 vertices. I calculated my vertices. The next step says to plug my vertices into the profit equation. All right, so I'm going to plug all of them into this equation right here. I'm going to start with P equals 3, let's start with this point, times 0 plus 2 times 5. I get 10, right? All right, let's go this way. I have P equals 3 times 0 plus 2 times 0. That's 0. We know that's not the maximum amount. Go to this one. P equals 3 times 4 plus 2 times 0. That's 12. And I got to do this vertice yet. P equals 3 times 3 plus 2 times 2. Which is 9 plus 4 or 13. Okay, any question how I plugged them into the profit equation? Okay, now I'm looking for a maximum. Move this up a little bit. Which one of those numbers is the maximum? All right, so I'm going to ask that you circle where you got 13. And all I'm going to ask you to write is a max at 3, 2. I mean, you can say a max of 13 at 3, 2 if you want. Correct. Okay. Vance. Yep. Correct. Okay. I'm going to do, we're going to do this all week. Okay? All week with 3 problems, right? We'll see. Maybe 4, maybe 2. All depends. Shh. Guys, listen. Yep, exactly. I'd like to do one more example. Okay, one more example. It's a little bit different, but let's try it. Example number 2. I need you listening. Example number 2. We have 2 less than or equal to x less than or equal to 6. We have 1 less than or equal to y less than or equal to 5. And we have x plus y is less than or equal to 8. My profit equation this time is 3x plus 2y. And I am looking for a maximum again. All right. So the first thing is, I'm going to put my graph up here. I did this one because it was a little bit different. This means if I have my x's between 2 and 6. So I'm going to go to 2, and I'm going to make a vertical line, because that's x equals 2 is a vertical line. All right. I'm going to go 3, 4, 5, 6, and I'm going to make a vertical line there. So right now my feasible region would be between those 2 vertical lines. Okay, we're going to do y. Okay. So in this one, I have a horizontal line at 1, and I have a horizontal line at 5. So far, it's in that square, or rectangle area, right? I have one more equation to graph. Does x plus y less than or equal to 8? So if I put 0 in for x first, what does y equal? If I put 0 in for y, what does x equal? Good. So, let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's 1. And at 6, 7, 8, here's my other one. I'm going to connect my dots. And I'm going to shade the feasible region, which is this area right here. All right, now let's look at it. We have 1, 2, 3, 4, 5 vertices this time. Don't give me that look, Kaylee. All right, some of them are really easy, though, to find. This one sits right on a vertical and horizontal line. This vertex here is at 2, 1, 2, 3, 4, 5, right? This vertex is at 2, 1. This vertex is also on our rectangle, which is at 6, 1. Perfect. The other two are on a diagonal line, so we got to do a little bit of work. Okay? Let's start with this one. This one is on where y equals 5. So I'm going to plug 5 into my equation. X plus 5 equals 8. Means that x equals 3. So this point over here is at 3, 5. Now we got to do this one. In this one, y equals, whoop, I sure did that wrong. Yeah, x equals 6. So again, I'm going to plug it in this equation. I get 6 plus y equals 8. Y equals 2. So this point over here, the vertex is at 6, 2. So now that I have 5 vertices, what am I going to do with those 5 vertices? Exactly. We're going to plug it into the profit equation. A little too far. Okay. All right, so here we go. We're going to start with the 0.25. So P equals 3 times 2 plus 2 times 5. That's 6 plus 10, or 16. All right, you guys want to go clockwise around or counterclockwise around? You think so? Well, let's try that one next. We have 3 times 3 plus 2 times 5. Okay? All right, let's continue around our figure. We have 3 times 6 plus 2 times 2. Good. Next one, we have P equals 3 times 6 plus 2 times what? Good. 20. And the last one we have P equals, holy cow, I don't know what I wrote that for. 3 times 2 plus 2 times 1, which I agree is 8. All right. And again, we're looking for a maximum. What number is the maximum? 22. Not what you would have thought, huh? So we say max at 6, 2. All right. Questions? I'm trying to give you 5 easy steps to follow today. Now, we just did problem 12, so you only have 10 and 11 to do. I'm asking you to do 2. That's it. Okay? All right? You do not have to write 12 down if it's in your notes. Okay? 10 and 11. 10 and 11. Sometimes yes, sometimes no. Sometimes it's bigger than that, but you're welcome to try.